IGCSE students, welcome back. Today we're going to have a quick chat about congruent and similar shapes. First of all, I'm going to talk about congruent shapes. So if something is congruent, it's exactly the same shape and size. That means all of the angles of the polygon are going to be the same and all of the sides are going to be equal in length. So if we look at this first question I've got here, question 1, write down the letters of the triangles that are congruent to our shaded triangles. So what I'm going to do is I'm going to find everything that's exactly the same size and length of all of these sides of the triangle and angles. Now what I've done is I've looked at the bottom, this base, it's a 4 and the height is 2 and it's an isosceles triangle. So I've just got to look for that anywhere. Now it could be flipped, mirror image, it could be turned, rotated in one direction or the other. So I've just got to be aware of that. And I can see that this one here is like a rotation of it. You've got 4 down, 4 on the base here, and then 2 up that way. So that's going to be one. That's congruent. So do I have another one? Oh yes, this one here. This is like a flip, isn't it? You've got 4 across, so that's a base, and then 2 up. It's an isosceles, yeah, perfect. Oh, here's another one here by the looks of it. We've got 4 for a base, 2 up, another isosceles, so that's congruent. Are there any more? I think we are done there. Now let's talk about similar. So similar we're going to do in purple. Now similar, they're going to have the same kind of ratio of sides. So we've got a 4 base and a 2 height. So you could think base, height. So anything that fits into this ratio here and is isosceles is going to be okay. Well, let's have a look at this one here, D. D has a base of 2 and a height of 1, so yes, that's okay. Let's look at A. It's got a base of 3 and a height of 1. No, that's not going to work. It's not the same, so not that one. E. This has got a base of 4 and a height of 3. That is not in the same ratio, so we can ignore that one. Let's have a look at C here. 1, 2, 3, 4, 5, 6 to 2. Well, clearly that's not going to work because we've got 4 to 2. 6 to 2 is not the same. So look at this one here. We've got 3 across and 1.5. Now is 3 to 1.5 the same as 4 to 2? Well, yes it is. If we divide both of them by 1.5, we get 2 to 1, which is of course the same as 4 to 2. So yes, this is similar as well. Now let's have a look at this H business. 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4. Yes, that is definitely in the same ratio, 8 to 4. So I'm good with that. This one here is 1, 2, 3, 4, 5, 6, and it's 6 to 3. And 6 to 3 is the same as 4 to 2. So yes, that's okay. This one here, 1, 2, 3, 4, 5 to 3. It's 5 to 3 in the same ratio as 4 to 2. Well, no it's not. So we can ignore that one there. Okay, well that's our first question. Now the second question I'm looking at is ABCD is a rectangle, the diagonals AC and BD intersect at points E. So I've just sketched this pretty quickly here. And I've got to prove that triangle BEC, now I will sketch that in with blue, BEC, so this triangle here, I've got to prove that it is congruent to AED. Now the way I do that is I know that this angle and this angle are equal, okay, because they are vertically opposite. I know that this and this and this and this are all equal in length, and therefore, and I also know that this is equal in length to that one, so we have all sides are equal in length. Therefore, these triangles must be congruent. And I would do much the same thing with DEC being congruent to AEB. just quickly, if we do this in green, you see we've got this triangle here, and we've got another one down here. This length at the top and the bottom is the same. We've got an equal angle here because they're vertically opposite, and these sides are also equal. So all sides equal, so the triangles must be congruent. Let me now move over to C over here. This is question, I think it might be 3C. I'm not entirely sure. Let me just quickly check. Yeah, 3C. We need to find out the missing angles and sides, and we're told that the shapes are similar. I hope you can see that we probably want to spin this top shape around so that this pointy bit here matches that pointy bit there. Let's work on the angles first, because the angles aren't going to change if if polygons are similar. It's the sides that will change in length. The angles will always stay the same. So we can say that Z is equal to 18 degrees because it matches this angle here. Okay, and then we can say that Y is equal to 119 degrees because that corresponds to that. Okay, now we've got to see the enlargement factor at this point. So let's just see what corresponds with what. When we flip this around, this 3.9 corresponds to the W, and let's see, what else have we got? This 4.5 corresponds with the 7.5, so this is going to be where we get our enlargement factor from. And what else have we got here? We've got a 3.5 and an X corresponding. So let's use the 4.5 and 7.5 to find out what the enlargement factor is. So I'm going to go 7.5 divided by 4.5. So when we do this, 7.5 divided by 4.5 gives us an enlargement factor of 5/3. So if I have, let's say 3.9, and I want to find out what this W is going to be 3.9 times 5/3. And so for W, I should get 3.9 times 5/3. That gives me 6.5. So I go 6.5. And if I'm trying to go, say, for example, from this 3.5 to the X, I'm going to go 3.5 divided by 5/3 is going to be equal to X, and therefore X is going to be, let's do that now, 3.5 divided by 5/3. That gives me 21/10, which is 2.1. Okay, team, so the next question, number 5, we've got to choose a statement, a word that fits the statement here. So we've got to work out whether triangle PQR and triangle PST are what. So PQR is this triangle here, and PST is this triangle here, all the way up here and all the way down here. Okay, so what are they? Well, they're obviously not congruent, nor are they isosceles, nor are they equilaterals. So the only option is similar. That makes sense as well. We know that this angle is the same for both of them, and then everything else is going to be in ratios because we've got these two parallel lines here. Okay, now what are we told? PR is 12, QR is 18, and RT is 24. Okay, I've put that in purple because it represents this whole length along here. Okay, we've got to calculate the length of ST, so we want to know this one here. Okay, here's what we do. We know that if they're similar, the ratio between RQ or QR, the ratio of QR to PR is going to be equal to the ratio of ST to PT. Okay, sorry, I think earlier I said 24 was this whole length here, but it's only from R to T. So let's put in what we know here. We know QR is 18, and we know PR is 12. And then let's see what we know. We're trying to find out ST, so I can stick ST here. And let's see, PT is 12 plus 24, which is 36. Okay, now we can simplify this to work out what ST is. So I'm going to say 36 times 18 all over 12 is equal to ST. Cancel 1, cancel 3. So 3 times 18 is 54. That is the length of ST. Now the final section in this question is asking me to find the area of PST. Now, what we want to do is first of all find the ratio of lengths. Okay, now to find the ratio of lengths, we see that PR is 12 and PT is 36. So we've got a 1 to 3 ratio. Now we know that the ratio of areas is going to therefore be 1 to 3 squared. Now you might be wondering, why is it 1 to 3 squared? And it's very simple really. Imagine we have a little square like this, and it's 1 by 1, and we'd say it's 1 centimetre. Now let's say I times all of those lengths by 2, and now I will have a square roughly like this. It's a funny looking square. So I'll have 2 by 2, and my area will be 4 centimetres squared. So the ratio of their sides is 1 to 2, so that's the ratio of lengths, and their ratio of areas is 1 to 4, or 1 to 2 squared. This is why the ratio of areas in this case is going to be not 1 to 3, but 1 to 3 squared, because area is length by width. Okay, so we're going to have a ratio of 1 to 9, or 1 to 3 squared. Now, the area of PQR, which is the smaller triangle, is 90. So what's the area of the larger triangle, which is PST? So 90 to what? Well, what have I done here? I've times by 90. So I'm going to do the same again. Let's see, 810 should be our result for centimetres squared for that last part. Alright guys, I'm just going to try this last question with you now. We've got a pair of similar cylinders. You can do the pyramids on your own. I've got to find the ratio of their surface areas and the ratio of their volumes. Step 1, ratio of lengths. And we can see that that is 5 to 7.5, and we simplify that to 1 to 1.5. Therefore, the ratio of areas, or surface areas, is going to be 1 to 1.5 squared. Now, you could simplify that. 1.5 squared, what's that? 2.25, yeah. So it'll be 1 to 2.25. And finally, the ratio of volumes. Now, remember, with area, we said, well, it's going to be squared because we're dealing in 2 dimensions. But if everything is being increased by a 1.5 times factor, when you're doing volume, it's going to be 1 to 1.5 times 1.5 times 1.5, or 1.5 cubed. So we say simply 1 to, and this is 27 over 8, or another way of writing that is 3.375. Now, it might be written slightly different in the answer book. but those ratios are correct. Let me know how you get on with this exercise. It's a bit of we've done a very quick introduction into similar shapes, congruent shapes, and how to work out areas, lengths, and volumes in similar shapes. Okay guys, good luck.